Okay, over on the back side, let S be the region between the curves cubed root of x and x squared minus 2. So part A, enter the two curves into your equation editor and pull up the graph, draw a brief sketch of the curves in the space below, and label each function. All right, so we're going to get our calculator. Let me get it off so the light's not shining on it. There we go. So there's our two functions. And if I'm going to start with a zoom 4, it's a nice one to start with. Zoom 4 gives us this curve. There is our cube root of x. And here is our x squared minus 2. So we can see that if we want to close in a little bit, we have negative 2 to 2 for our domain, should cover most of it. And then negative 3 to 3 for our range. So I'm going to go to Window, I'm going to type in negative 2 and 2, x scale can be 1, negative 3 and 3. And by doing so, and now looking at the graph, this might be a good one to place on your paper, where you can see there's our x cubed, and then here comes our x, or rather the cube root of x, and there's our x squared. So we're looking at that region right there, and now you can copy that onto your paper. I'm not going to take the time to do that at the moment. Part B, use the equation solver on your calculator to find the x-coordinates of the 2 points of the intersection between F and G. Okay, so we're going to bring this back. So I did say use the equation solver, which you can absolutely use. You can also use the intersect command. The intersect command is second trace, and we see it right there, option 5. So it says it wants the first curve, so we just hit enter on the first curve, and then it wants the second curve, so we hit enter again. And now we have to figure out where to guess. Well, if you guess close to this point, it'll find that point. If you guess close to that point, it'll find that one. So this point happens, it looks like right at negative 1. So let's guess negative 1. And sure enough, it verifies that x equals negative 1 is the first time that our two functions intersect. So now we're going to repeat this process. So second trace, option 5, and first curve enter, second curve enter. But this time we're going to guess over here because we want the second point where they intersect. This is x equals 1, this is x equals 2, so we want a number between 1 and 2. So let's go with 1.5. When we hit 1.5, we see our second value, which is x is equal to 1.793. All right, and part B is now done. So part C, write an integral which represents the area of S. Okay, so we have the integral, and our low bound is negative 1, our upper bound is 1.793. We have to figure out which curve goes first. We can see here it's the blue curve, which is the cube root of x. So we'll have that one first. So cube root of x minus, and then in parentheses, x squared minus 2, because we need to subtract the entire function. That whole thing gets a dx. Now part C is done. And then part D says use your graphing calculator to solve the integral and make sure your solution is accurate to a minimum of 3 decimal places. Okay, so we're going to bring this back in. We're now going to go to the main screen, so we're going to get out of there. We want math 9. Our bounds are negative 1 to 1.793. And we have our cube root of x, which is located in y1, so alpha trace y1, minus the x squared minus 2 curve, which again we see is located in y2. Alright, so we're going to put in minus and alpha trace y2, and our differential is a dx. So give it a second to figure this out. And it comes back with 4.215, which we can write, went off the screen there. You can write 4.214, you can write 4.215, you can write 4.2149. All those answers would be correct. You just want to make sure that you have at least 3 decimal places.